Welcome. Now we're going to go on to hyperbolas, which are very similar to ellipses in the sense of the equation looks exactly the same, except we have a minus rather than a plus. So we still have our x minus our horizontal shift for our center squared over a squared minus y minus k squared over b squared equals 1. Now, the thing about hyperbolas is they're not ovals. They're they look like parabolas, two parabolas back to back. Now, we could have them opening what we call left and right. Opening left and right is if the x is this one that's being squared, if the x is the one that's positive. If you're subtracting the y squared, it's open left and right. If x squared is positive, you're open left and right. If the y squared, if you notice here in the first term, the y squared is positive and you're subtracting the x squared, in other words, I like to think of the x squared as being negative, or the y squared is positive, then it's opened up and down. One other major significant difference between ellipses and hyperbolas is in ellipses, A is always the largest. That's not true in hyperbolas. In hyperbolas, A can be smaller than B. A is always what the distance from the center to the vertex. And so I'm going to talk a little bit about some of the technicalities of the hyperbolas. So let's look at this diagram here. The thing that's most important to realize is that a hyperbola, similar to an ellipse, it's not called a major axis though, it's called a transverse axis. A transverse axis is the distance from vertex to vertex. So the two hyperbolas, they have a vertex at the tip of each of the curved U-shapes, and the distance clear across from this vertex all the way to this vertex is called the transverse axis. Now, hyperbolas don't have covertices, but the distance across this rectangle is called the conjugate axis. Now, I want you to realize that the conjugate axis can actually be a lot longer than the transverse axis. This is the transverse axis, which is short. This is the conjugate axis, which is long at this point. Or I can extend this out and make the transverse axis longer than the conjugate axis. Now, let's talk about our values A, B, and C. A is the length from the center of this rectangle, or the midpoint in between the two vertices of our hyperbola and a vertex. That's the distance A, or half the transverse axis is A. Half the conjugate axis is B. Now, let's figure out how to find A and B so we can also find C. Now, one thing I want to emphasize about C is the distance from the center to the foci. So from the center to the foci C, which is also this distance along from a vertex out to the midpoint on the side of this rectangle. Now, Pythagorean theorem actually holds in this one. It is the normal way. It's not like ellipses. This one is a squared plus b squared equals c squared. So in order to find the distance from the center to the foci, you actually add a squared to b squared and then square root. But if you notice, we have these lines of asymptote lines. If you can remember when I talked about asymptotes, when we were talking about functions of graphs or features of graphs. If I was to zoom out, what you'll notice is these hyperbolas get closer and closer and closer to these lines, these diagonal lines that are asymptotes. And the way you figure those out is we're going to calculate this A and B. Now, by the way, we could, if I wanted to, turn this on this way so it's open sideways. Whoops, if I can get this to work for me here. That's the point I'm looking for. See, so I have it opened sideways. And now technically we could open diagonally, but that would be a lot more beyond this class. We're not going to do that. We're going to do it this way. So now I'm open sideways. Again, my center, I'm going to move this, is here now. My transverse axis is now vertical. My conjugate axis is now horizontal. So I'm going to show you how to actually find all these values if you were given a problem. So if I go to, if I go to this here, here's a problem that you might see in your homework. Now, right here, the only thing I can really see is I can see what the center is, and I can see the length of the transverse axis. So I can find my distance A. It's from the center to a vertex. So my distance A, so I'm going to write that up here somewhere. Change this to a different color. A is 4 units because the transverse axis is 8. From here to here is 8 units, or we got 1, 2, 3, 4. Now, to find my value of B, what I do is I think of a rectangle, and what we do is I start at the vertex and I either do a horizontal or vertical line until I hit those asymptotes. See, so I'm going to come out that way and I'm going to come out this way, and I'm going to do the same thing on this side. Again, you really don't need to do both top and bottom. You really just need to do one, because what we're looking for is the value of B, which right here, this asymptote line crosses at, right, that's up a little high, but right there, right here, I want that to turn, there we go. So I can see that my B value, which goes from here, be careful, don't go from the x-axis, but from here it goes up 2 to 7, that's a total of 5 units. So my B value is 5. So now that I know what my B value is, I can easily write the equation. Oh, by the way, the center is -4, 2. So now I'm going to use my equation. Now this is opened left and right, so my x comes first. I'm going to go x minus off my x value. Now my x value is a -4, so it ends up becoming +4 squared all over a squared, the half my transverse axis, which is 4 squared, so this would be 16. Now this is a hyperbola, so I'm going to minus y, minus off my vertex's y value, which is 2. That's going to be squared all over my b squared. Now b is half my conjugate axis, which is 5 squared is 25. And just like an ellipse, it's equal to 1. And I've written the equation for this hyperbola. And I didn't need very much information. I just had the center. I had these lines or asymptote lines and the vertices. And so some of the problems you might get might actually just give you those values rather than giving you a graph. Try working on the homework. If you have any issues, please log on and ask me via Zoom.